So let's take a look at our next topic, and that is finding outputs of a one-step function that models a real-world situation. And here we're going to be using function notation. All right. And so in this example, we have a plant is already 58 centimeters tall, and it will grow 1 centimeter every month. The plant's height, which is defined as h in centimeters, after m months is given by the following function. So the function is h of m is equal to 58 plus m. And we are asked to find what is the plant's height after 31 months. Okay, and so notice with this particular example in function notation in the earlier topics, you were asked to go through and actually create the equation, the linear equation from the information given. And remember that's a linear equation, y equals mx plus b. Okay, and so remember that in this slope-intercept form, that be the y-intercept. Remember that represented essentially the starting point of your application, and the slope m, remember that represented how the application either grows or decays over time. Okay, increases or decreases over time. All right. And so notice that this particular function satisfies what the word problem is given to us to a T. Notice in this case, we're told the plant is already 58 centimeters tall. So that is your y-intercept. It's 58 centimeters tall. Okay, so that's our start point. And notice we're also told that the plant is going to grow 1 centimeter every month. So that 1 centimeter is acting as your slope M. Okay, and so ultimately you have, in this case, really 1x plus 58 or x plus 58 as your equation. And that's notice exactly what we have here. They're just using different letters. Okay, so just kind of making sense of what we talked about earlier, applying that to this example. And so with the function, remember that m is your independent variable representing the number of months, and h, remember that is your dependent variable, that is the height of the plant in centimeters. And so we're asked to find what is the height, what is the plant's height after 31 months. So notice in this case, really what we're looking for is we want to find then the height, we want to find the height h, okay, when m, the number of months, is 31. Okay, so we want to find the height h when m is 31. Okay, or simply evaluate this time h at 31. So we're going to evaluate h at 31. And of course, to do that, we're just going to plug in 31 in place of m in the function. So that's going to leave us with 58 plus 31. And of course, add that together, and that's going to leave us then with 89. And don't forget your units, so 89 centimeters. All right, so this is telling us then when the plant started at 58 centimeters in height, after 31 months, it grew to 89 centimeters. Okay, and in a similar example, we have another linear equation in function notation. And so an amusement park charges an admission fee of $30 per person. The cost C in dollars of admission for a group of P people is given by the following function. Okay, so our cost function is C of P is equal to 30P here. So what is the cost of admission for a group of 5 people? Okay, so again, P is our independent variable representing this time a group of people, and C is the cost in dollars, okay, for that group. So in this case, once again, to find that cost for a group of 5, we want to go through and find, again, we want to find the cost. We want to find the cost C when what? When P is equal to 5. Okay, so that's what we're looking for. Okay, or again, we just simply want to evaluate then C at 5. And of course, plug that in. So it's just going to leave us with 30 times 5, which of course is going to give us $150. So the cost of a group of 5 people to go to the amusement park will be $150.